Hello everyone, welcome to the Switch List. My name is Rick. In today's video I wanted to show you a project that I have been thinking about for a little while and finally decided to give it a go. So one of the things that I think is really cool is when you have lighting on your buildings, and you've seen in some of my videos I've done a little bit of lighting so far, but beyond just having static lighting in the buildings, I think it would be kind of cool to have some animation in that lighting, meaning things turn on and off kind of randomly over the course of an operating session or a day or whatever you want to call it. So I started thinking about, well, it seems like that would be fairly simple to do with an Arduino, and then I said, well, if I got you could use an Arduino Nano, and very simple, project to just control the digital pins to turn things on and off. You do some random number generation in order to put some randomness around it. But then I was like, well, I want to be able to not only just have the Arduino, like have one Arduino per building, so which would be a real waste if you were going to have one or two lights in a building to put an whole Arduino. So I started thinking about, well, how could I do it so that you could use a single Arduino and control all of the digital I/O, which I think is 20 or 22 total I/O pins that you have access to, that you could control lights with, but have that grouped in buildings. So I put together a sketch where it defines light groups, which for each light group that is considered one building, you say for a light group how many lights are in that group, how many lights does that building have. And then you can actually also assign the likelihood of a light changing in that building for each loop through the code. So if you want to have the lights changing frequently, you put a high probability number in, probably 1 to 100, a high number in there. If you want them to change very infrequently, you put a low number in there. So anyway, I started working on the sketch, and I've got it working, and we'll go through the code here in just a minute, real quickly, not a deep dive. We'll do a quick review of the code, and I'll show you it here, breadboarded up. Ultimately, what we're going to do is after I got through the code, we go through the breadboard. I bought 3 of these Nanos from Amazon. I think it was $12, $13 for 3 of these, and I've actually successfully programmed them with the sketch, although it wasn't completely straightforward. I had to use the old 328 old bootloader for some reason. But anyway, we managed to get it done. So what I'm actually going to do after we walk through the code is I've got a couple buildings that I slapped some rooms in, if you will, to allow me to have one building that has 4 lights. The second building will have 3 lights. I'll have them set up on the bench with LEDs inside the buildings and the Nano running, and we'll take a look at how that actually would look in an actual layout. And of course, if there's 20, I think it's 22 total, but I'm not using 2 of them because those are RX and TX, and I need those for the monitor port on the Arduino for debugging. And yes, I had to do some debugging to get this to work. But so you could literally have 20 buildings of 1 light each, or you could have, any number of buildings with any number of lights. So in the case, I'm going to show you 2 buildings, one with 4 lights, one with 3 lights. So anyway, stick around and we'll take a look at the sketch and see what it looks like in some actual buildings. I'll be right back. Okay, so I'm going to go through a very quick overview of the code. I'm not going to delve too deep into the details here, but just kind of give those of you who are interested a little bit of information. So as I mentioned, the idea here was to use ultimately a Nano and to have a way to group the digital pins together into one building and have multiple buildings defined so that you could control the lights in multiple buildings individually. The first thing I'm doing is I'm doing my global definitions here. I'm defining a debug variable, which allows me to turn the debug on. It puts stuff out to the serial monitor port. I have a pound defined here of 1 change per loop, true, which means that the way it's going to perform right now is that only a single light in each building will change in any given iteration. If you want to have the ability for any and or all of the lights to potentially change within the building in one loop, then you would set this to false. I define first digipin as the first digital I/O pin, which is number 2 in this case. I'm not using 0 and 1, which are RX and TX because those are needed for the serial monitor. You could use them if you're going to burn this into an Uno with no serial communication. You could use those pins as well. In this case, I've defined the last digipin as 8. So right now I'm using pins 2 through 8. The total number of digipins is 7. I've redefined false and true to all caps just because I prefer that. Then I've defined the number of light groups. So a light group is essentially a building. In this case I'm going to do 2 buildings. I have some pound defines, just turning individual index numbers 0 through 4 into light group 0, light group 1, again just so that I can have human readable words throughout the code. There's a delay time here of 1,000. This is the number of milliseconds to delay between the iterations of the loop. Right now I have this set to 1,000, so that's 1 second. Normally I was thinking 600,000, which would be 10 minutes, so the lights potentially change within the buildings every 10 minutes. This can be as much as you want, up to something on the order of 47 days is the largest value you can put in there. Then I have a delay after change multiplier, so I have a random number generator that generates a number from 1 to 10, and then it multiplies that times this number to get milliseconds to delay after a change. The purpose behind this was this idea that I didn't want to have if you have 2 buildings side by side being controlled, I didn't want to have, light go on one and immediately go off on the other, or just have simultaneous. So this puts a random delay between if I've changed a light in the first building before I'll do anything in the next building. So those are all my global constants. So then my setup loop is very simple. I simply loop through from the first digipin to the last digipin, set it as an output, and set it to low initially. Then I seed the random number generator by just doing a read of analog port, which gives you some random value, which then seeds the random number generator. I'm going to skip all the if debug stuff. Again, this is all just to put stuff out onto the serial monitor while I was debugging it. Did a light test. This was because I had a bad wire. One of my wires connecting the Arduino to the breadboard was actually bad, and I was trying to figure out why the LED wasn't on, and so I just put this test in the beginning, so when it first runs it just lights up each LED so that I know that they're all working. And that's very simple setup loop. Then we move into the main loop. So I define a couple of variables here. I define an array called light groups with an index of however many light groups I've defined. If you remember, in this case there's 2 light groups, and then I have an array to hold the probability of any light changing within that individual light group. So for each light group you can control the likelihood of a light going on or off, and I'll show that a little bit later. Then I have an array of Boolean called light status. All this is doing is keeping a track and a variable of what the current state of every digital pin is, either true or false, on, off, and I use that primarily in the debugging process. So now I go ahead and I initialize that array with variables, and you'll hear I set it to a 1 and then I set it to a 0, and the reason behind this is I'm seeing something very strange on pin 7. It's reading back sometimes as 20, sometimes as 40. I mean, I went through a lot of craziness trying to figure out what the heck was going on, and once the pin gets written to a high, then it seems to behave normally. Very, very strange behavior. So I was playing around trying to figure out, is there something in the initialization of the array variable? So you can ignore that. Ultimately I'm setting all of the, because I turned all the lights off, set all the digital pins to low, I'm setting all of the statuses to low in this array. This is a bunch of more debug stuff. I have a variable called current group, which keeps track of what group I'm in or what building I'm dealing with, and then I have a variable that keeps track of which particular light within that group I'm dealing with. And then there's this base light number. This is because it treats every building as lights 0 through whatever the max number is. You have to have some base number. So in the beginning, base number is set to first digipin, which is 2. So the base light number, so it's going to start with 2, and then it will increment from there. And then when you move to the next group, it will adjust this base light number to add however many lights were in the first group. So now for the second group you'll be starting off with the correct pins within that group. I have a Boolean variable that holds the current value of the pin, the output pin, and then a Boolean, which is the new value of the pin that's going to be written when a change occurs. I have a flag here that keeps track of whether a light has been changed. This is used in that idea if you want to limit the number of lights that can change within a building on any given loop. Once you've changed a light, this is set to true, and then I know that I'm not going to make any further changes for that group or that building during this iteration. I also have a variable that's set to the value of whether of the one change per loop constant that we defined above, and this variable I use to determine whether or not you're limiting the number of lights that can be changed in a single iteration. Next thing we do is we say for each light group, so in this case light group 0, I have 4 lights in that group, and here and I need to edit this comment, and then the group light change probability for light group 0 I have it set to 40. So, and then I define light group 1 has 3 lights in it, and the probability is currently also set to 40, but I could change that. I can make that 50 or whatever I want. And then all of that is the setup in the loop, if you will, and then we go into a while true. So this is the main loop. I couldn't just use the natural looping ability of this code because there's some initialization of variables that would keep reoccurring, and that messes things up. And yes, I found that out the hard way. I'm not thinking. So now what I'm in this infinite loop, but while true, I do all this stuff. So while the current group that I'm looking at is less than or equal to the total number of groups, then I drop in here and I say, then I start cycling through each individual light. So for light num equals 0, light num less than or equal to the total number of lights in the group, and then I increment it each step through, and I say if light change is false, or if one change limit is false, so if I've turned off the requirement to limit thing, and then if my random number of 1 to 100 is less than or equal to the probability that I've defined. So when I set it to 30 or 40, then if the random number that it generates between 1 and 100 is less than that, then we're going to go ahead and change the light. So basically test all those things, drop in here. I read the digital pin to get the current value. The new value becomes the inverse of that. Then I write that inverse value out to pin to toggle the status of the light. I also then update the array which holds the value of each of the digital pins, and I set the light change flag to true, indicating that we've changed a light. Then the next thing I do, so that loops through all the lights in a given group. Then we drop into the next group, and so before we start the next group, I add the number of lights in the current building or light group to the base light number. So in this case, the first building has 4 lights, so and it start off with a base of 2. So now the base number will become 6. 2 plus 4, so it's 6. And the second building is lights 6, 7, and 8. The first building is 2, 3, 4, 5, and the second building is 6, 7, 8. I increment the group that we're looking at. If I've changed a light, then I go ahead and I do a delay, and this again this is where I call and I use that delay after change multiplier. Oh, I keep doing that. So this is where I do a random delay of 1 to 10 times whatever my multiplier is, which currently is a second, so it's 10 seconds. And then I continue to loop through until I've gone through all of the groups one time. After I do the delay, then we reset the flag that indicates the light has changed, and we delay a set amount of time. This is the time, again, 10 minutes, whatever, before we go through the next loop. We reset all of the variables that we need to reset. The current group goes back to 0, light change is false, and the base light number is the first digipin, and we go back and we do it all over again. So let me, hopefully you'll be able to see that. So I can set it down so it'll be more steadier. So I'm going to hit the reset pin, and you'll see check all the LEDs. Okay, now it's turned the second light in the first building on, and now it's going to do its delay, a random delay. Now it turned on the second light in building 2. Again, the random delay or the delay between iterations will occur, and then it'll go back, and it may or may not change based upon how much you see set. It didn't do anything in the first building, but it turned a second light on in the second building. And here now it's turned a second light on in the first building, and this will just continue on, randomly turning the lights on and off. So that's a quick look at the code and the circuit. So now let me get out of here, and we'll go over and take a look at what I set up on a couple of buildings to take a look at what this looks like actually running. Okay, I have a few minutes to kill before Amazon shows up with the actual LEDs I'm going to use to put in the building, so I thought I'd just take a minute and show you the buildings that I'm putting them in and how I've prepped these so far. So the first building, this is the building that's going to have the 4 different lights in it. This is a DPM Valley Apartments. I think it's also called Townhouse Number 3. I'm putting floors in, if you can tell here. So I'll have 3 separate floors, and then I've got in this a wall here, and I think a wall on the bottom to divide this up into rooms. So what I'm thinking I'm going to do is I'm going to have 2 lights on the top, 1 in the middle, 1 on the bottom. You can see I've got 2 wires coming up here. These are the positive connections to the LEDs. What I'm going to do for the negative connection, since they're all common, the LED strip that I bought comes with double-sided tape, so I will stick 2 of the LEDs. I'm just cutting them. They're very similar to these. However, these are 12-volt LEDs, and they won't turn on using the 5-volt output of the Arduino Nano. So I ordered some 5-volt version of this, and you can just cut these. The one I bought, they're designed to be cut into individual LEDs. So they have double-sided tape, so I'll stick 2 of those onto here. I will wire the negative connection of one to the other, and then take a wire down through that will ultimately go down to the common. We'll see in a second. And then obviously the 2 red wires will connect to the positive leads. We'll do the same thing. You can see this is the underneath of the top floor. I'll stick 1 in there, again wiring it the same way, bringing down the negative connection from up above to tying it to the negative connection there, and back down. This here is the negative connection. You can see that. And then finally I will put the floor in, and I made all these floors and walls out of good old priority mail boxes that I've received stuff in. This stuff works really good for that kind of hit it with some spray paint just to color it a little bit, hide the U.S. Postal Service stuff on it, and then build some walls. So I'll put this floor, after I put the LED in there, wired it up, I will then add this floor. Probably before that I will put an LED here as well. And so anyway, put the floor in, add the LEDs, all this. And as you can see, I bring all the wires and tie them into this header. This is a 5-pin header. 1 lead is the negative connection, and then there's 1 lead for each of the LEDs in the building. And I'm using this same setup that I used, if you saw the McComas Brothers building that I did for Bel Air, for the lighting that I did on that. The same idea where you can plug the mating pins into there, and that way you can unplug it, remove it from the layout, and not have to undo any wiring. So that's that one. And then the other building I'm going to demonstrate this in is this another DPM kit station. And so inside of here I did the same thing. I've got, these are just temporary walls that I cut out and I'm sticking in here. Again, the whole purpose is to give me separate rooms. Hopefully they'll provide enough blocking of the light. We'll see once we get done. And then I have the same idea where I have my, in this case it's a 4-pin header because there's 3 lights and a common, and I run them up, tape them. If you can see there, you taped them down with Kapton tape, and then these will again, I will daisy chain the negative across, take one of the red wires to each of the LEDs, which I will go ahead and stick on here, 1 above each room, tie them in, stitching, and Bob's your uncle. We will have buildings ready to be lit up by the Nano. So as soon as the LEDs get in here, get them installed. I'm not going to bother showing you how I did that, and then we'll get to seeing how the light animation works with the Nano. Okay, here we are on the bench. I've got, you can see here, I've got the Arduino connected into the building on the left has the 4 lights, the building on the right has the 3 lights. I've got it all wired up and ready to go. So what I'm going to do now is I'm going to plug in the power supply for the Arduino, and what you'll see is you'll see the 4 lights in the building on the left go on and off as part of the light test, and then you'll see the 3 lights in the station building on the right go on and off, and then they'll start to randomly go on and off. So here we go, plugging it in. And remember, I've got this set right now so that it's going to go through this fairly quickly. Normally, as I said, I was thinking it might go through the iteration of the loops once every 10 minutes or so in order to just put some animation in the lights of the buildings on the layout. So I think it worked out pretty well. As you can see, the lights are going on and off. And I think it came out pretty good for a fun project. It took me about 2 days to do, and if I can remember, I will put a link to the LEDs that I used, as well as the Nanos that I bought off of Amazon, so if anybody's interested. So there you go, another project successfully completed. Ways to go on the buildings, obviously. I gotta put some curtains in, put some interior detail. If they're gonna light up like that, you ought to really be able to see something. But anyway, I think that the lighting project worked out pretty good. Thanks for watching. Okay everyone, that'll do it for this video. I hope you found that interesting and informative, and if nothing else, at least enjoyable. So maybe you want to give that a try. If you have any questions about the code or any questions about what I did, please feel free to send me an email. My email address is listed on my channel under the About page or whatever it is. I'd be more than happy to answer anybody's inquiries via email about the code, or if you have any questions about why I did something the way I did it. And certainly be interested in anybody who takes it, improves on it, and let me know how you did. Thanks for watching. Please consider giving me a thumbs up and subscribing, hitting the bell icon if you like this video and you want to see more content from me in the future. So everybody continue to stay safe out there, and I will see you down the rails.